Hello, Miss Barron here. So I'm going to be reviewing how to do molar mass, how to calculate that, and then how to use that in picket fences to convert between moles to grams and grams to moles. This is a skill that we have used almost the entire year in chemistry. We use this all the time, but here's just a little bit more review on that. So I just took a snippet of my online periodic table that I use a lot. You, of course, can use your physical periodic table as well. So just to review, what is molar mass? Molar mass is how many grams of a substance you have per 1 mole of that substance, okay? And your periodic table actually tells you molar mass, okay? So this is on your P table or your periodic table. So for instance, carbon, if I had 12.011 grams of carbon, that would be equal to or the same as saying I have 1 mole of carbon, okay? So the molar mass of carbon is 12.011. Sometimes you might also see it written as 12.011 grams per 1 mole. A lot of times, these are both saying the same thing. I'm just writing them in a slightly different way. A lot of times I write molar mass like this when first going over it because you should be like, oh yeah, that's an equality and I can plug that into a picket fence. Okay, so your periodic table, these numbers here, these decimals, that on your periodic table it might say it's the atomic mass, which it is. It's the weight or the atomic weight, but it's also the molar mass as well. Okay, so I'm going to do a few practice problems, okay, and then have you do some on your own. So we're going to start by finding the molar mass of H2O, which is water. So first thing I'm going to do is on my periodic table, I'm going to find the molar mass of water. Or hydrogen, excuse me. So here I was just talking about an individual element, which was carbon. But now I'm talking about a compound that has multiple elements in it. So let's start with H, which is hydrogen. So I'm going to find that on my periodic table. So here's hydrogen. There's its molar mass, again, or periodic table might call it the atomic mass, atomic weight. So it's 1.008. So I'm going to go ahead and just write that down for hydrogen, 1.008. All right, and notice in the formula, it has the subscript 2. So that means I have 2 hydrogens. So I'm going to have to multiply this number by 2 because I have 2 hydrogens. Okay. Switch colors. Now we're going to do plus. And now we're going to look at oxygen. Okay, that's our other element. So I'm going to find oxygen on the periodic table. All right, here's oxygen, 15.999. As far as my class goes, I am fine with students rounding this up to 16. If you write 15.999, that's fine too. But I'm okay if you round up to 16. That's what I normally do. Okay? So I'm going to write down 16. Okay. And notice there's only 1 oxygen, so I only have to write 16. And now I just have to do my math to figure that out. Okay, so I'm going to do 2 times 1.008. I'm just going to hit enter, plus 16. So I'm going to get 18.016. If I go 2 decimal places, 18.02 grams per mole. Okay, I'm fine if you go 2 decimal places. Now again, just make sure you're being careful when you're putting things into your calculator. As far as, order of operations go, I like to do everything separate, and that's what I did here. Okay, so that's how we would find the molar mass of something like water. Now let's do a little bit more complicated of a formula. So find the molar mass of CaOH2. So again, we're just going to go in order left to right for each element. So I'm going to start with Ca, which is calcium. And I'm going to find that on the periodic table. So here's calcium. So 40.078. And I'm going to write that down. 40.078. And notice there is just one calcium. So I don't have to multiply that by anything. Plus, all right, here is the tricky part. So you'll notice that this OH is in parentheses, okay? So this is what we call a polyatomic ion. And this is on the back of your periodic table in terms of the formula, okay? You're not going to find the molar mass of it on the back of the periodic table, but just so you're aware, if I ever am talking about a polyatomic ion, this is what I mean, okay? So that's just a side note. So notice that it is OH2, okay? So since it's OH with the 2 on the outside, what I'm saying is I have 2 OHs, okay? So this 2 gets distributed or applied to everything that's in the parentheses, okay? So I'm going to, again, go in order. So I'm going to start with the oxygen. Well, we already found that one on our periodic table. That is 16. But notice that the 2, I know it doesn't have an O2 like this, but the 2 is on the outside of the parentheses is being applied to that oxygen. So I'm going to have to multiply this by 2. Plus, then we have our other element in there, which is the hydrogen. Remember, we found hydrogen earlier on our periodic table, which was 1.008. And that 2 is also being applied to the hydrogen as well. So I have to multiply this by 2. Now I just have to do my math. So I'm going to do this in parentheses, 2 times 16, and I'm going to close the parentheses, plus, and then I'm going to do another parentheses. Here, actually, I'll just do it in order. So we're going to do 40.078 plus, and then in parentheses, I'm going to do 2 times 16 plus 2 times 1.008, close parentheses, okay? Again, just be careful of order of operations. So I get 74.09 grams per mole. Okay. All right, so now that we've gone over how to calculate molar mass, now we're going to not only calculate molar mass, but also use it to convert between grams and moles. So for my first problem here, it says convert 46 grams of CH4 into moles. So usually if you're ever seeing something with grams and moles, most likely you're going to have to find molar mass. So first thing I'm going to do is I'm going to find the molar mass of CH4. So I'm going to start with C, which we did talk about that earlier, which is carbon. That's 12.011. Okay, and we only have one C, 12.011, plus, now we have the H, which is hydrogen. We already talked about that one earlier, 1.008, and notice it's H4. So I have to multiply this by 4. So I'm going to go ahead and find that. So 12.011 plus 4 times 1.008. Oopsie. Oh, I must have typed something in wrong. 12.011 plus, do parentheses, 4 times 1.008. 008. So 16.04 grams per mole. Now again, this is the same thing as saying 16.04 grams is equal to 1 mole. So if you have 16.4 grams of CH4, you have exactly 1 mole of CH4. Now I'm going to set up my picket fence. So it says to convert 34.6 grams, okay? So our picket fence, and we have to get that into moles. Well, this is an equality, right? And I can plug equalities into picket fences. So in the bottom, I always go here first. I know this has to be grams because these units are going to have to cancel out with each other. Well, how many grams? We'll look at the equality, 16.04. And if I put that in the bottom, whatever it is equal to has to go above it. So 1 mole. Grams will cancel. So now I'm going to do is the 34.6 times 1, which will be 34.6, divided by the bottom, which is just 16.04. So 2.16, I'm gonna round up, 2.16 moles would be my final answer. So now I have one more example. So again, I have to find the molar mass. So I have CaNO3 2. So we already found Ca earlier, which was, we'll go with the blue, we'll go with red first, which was 40.078, and there's just one of those. Plus, okay, now we have nitrogen. Nitrogen is 14.007. So 14.007. But see that 2 on the outside? It gets applied to the nitrogen and the oxygen. So there's just one nitrogen, and then there's that 2. So we're going to multiply this by 2. Plus, now we have oxygen, which we know is 16. But notice it's O3. So we're going to have to do 3, because you're saying you have 2 NO3s. So we know we have 2 nitrogens, but we have to do the 2 times 3 because we have 6 oxygens in total. Okay. So I'm going to go ahead and do that. So 40.078 plus 2 times 14.007 plus 6 times 16. So I'm going to get 164.092. And this is, or we'll just go 09 grams per mole, or 164.09 grams equals 1 mole. So then we can start our picket fence. Now this time I have 6.7 moles. So in the bottom of my picket fence, I know this has to be moles because these units have to be the same. Well, how many moles? Look at our equality. This is going to be 1 mole. And if I put that on the bottom, whatever goes above it, it has to be equal to 164.09 grams. So that way moles cancel, and I'm just left with grams. So I'm going to do 6.7 times that 164.09. Oopsie, 6.7 times 164.09. So I'm going to get 1,099.40. And this is in grams. And that would be my final answer. So then I have these 4 problems down here to try on your own.